So today I'm going to talk about what is a table in SQL. Um, and this is covering chapter 6 of the notes. So let's go over this very quickly. And I'll go back between the notes and SQL. So, so we've dealt with other tables before, but in SQL, a table has these 7 properties, which are every table in a database must have a unique name. Every column must also have a unique name. All entries in the column have to be of the same kind. The order of the columns isn't important. Every record, that's every row in the table, must be unique. And the order of the records, which is also the same thing as a row, is not unique. It is not important. You cannot have multiple values in the table cell. So you can only have one value. Okay. So those are the properties of what makes a table in SQL. And a table that has these 7 properties is called a relation. All right. This is somewhat different from what you see in Excel, because you see in Excel, you can have 2 columns or multiple columns with the same name, right? There's labels on the columns such as A, B, C, D that will make that distinction. You can also in Excel, you might have noticed if you're using formulas and you move the order of the records, the rows or the columns around, it messes up the formulas. That doesn't happen in SQL or in a relational database. So those are probably of a table. And as we create tables in SQL, you'll also see those properties being used. If you violate these properties, SQL will complain. All right. So what's the next thing we want to talk about? So those are relation. Now, what are the components of a relation? We can define a relation by the restrictions on its columns and the constraints on what values are in the records rows. So relations have 3 components. There's the columns, records, constraints. Okay. So what's probably a column? Well, a column, this can get confusing for people. How do you decide what column should be in a table? The rule of thumb that we use is everything in the table has to be of the same type, right? So if you have things all of the same type, they all have the same properties. And in the notes, it's talking about how if you have a collection of objects that with all the same properties, maybe for example, they talk about cups, right? You can have other things like you could have bicycles, you can have people. All of these things, they all have certain properties. Like a bicycle has what? Almost all bicycles will have 2 wheels. Okay, they have pedals. They have a size, right? They have a manufacturer. So all of those will differ, right? For individual, and then each bicycle will also have a serial number. That's how you can tell them each apart. Okay, people all have a first name. They generally will have a last name, and everyone has a birth date, right? Those are things that people will have to have. Other things we might not be, we can't always know for certain. Okay. They also have parents. Okay, but the parents in the first name, last name, birth date of each person might differ. Sometimes they might be the same, right? So those are the properties. So whenever we make a table, we make a table to be a collection of things that have the same properties. The columns are going to correspond to the properties. Sometimes you'll talk about in the relational theory, you hear two people talking about fields. And now, what's a domain? A domain is just the range of possible values you have in a column. Okay, so ages are going to be in integers, right? So ages are no one can have a negative age, right? So ages have to be between 0 and 150 years. Okay. Um, We might say, well, I can't think of anything else right now. Could think of other examples. Maybe, oh yes, you would say the social security number has to have a certain number of digits. Okay. Phone numbers in North America, they have a certain format, which is they have an area code, an exchange, and then the line number. Um, Clothes are made with certain things, such as they have, like, well, let me restrict it to just um, pants. Pants will have what? An inseam and a waist size, right? So you'll never see an inseam that's, um, you'll probably never see an inseam that's going to be a negative number, right? Okay, so that's give you an idea of what the domain is. Now, what's a record? The record is a set of individual values. So basically, a table is a collection of objects that all have the same properties, right? Each individual object is going to correspond to a record, or some other people think of it as a row. Um, and so we've talked about columns and records. Um, in relational theory, they don't talk about columns, they talk about fields. Okay, so we talk about columns and records. What's the other thing we mentioned? Back here, you see columns, records, constraints. So now let's talk about constraints. What is a constraint? Basically, it's a restriction on the table. And we have those constraints so that things don't get corrupted. Uh, you can other tables can reference what's inside the table, and we don't waste space by duplication. So these restrictions are called constraints, okay? And then they apply to the columns inside a table, okay? So there's the three types of dealing with the constraints that help us do three types of integrity, okay? There's primary key integrity, which makes sure that um, there's at least the column which is used to make sure each record is unique, can't be changed, or isn't dropped. That column, the columns that make sure that it's not that the records, that each record is unique, is not cannot that those columns cannot be changed and they have a value. There's domain integrity, which makes sure that the value in the column are in the correct range and data type. Okay. And then there's referential integrity, where we make sure that references between a column in one table can reference a column in the other table. Okay. So those are the three things that we use for making tape that the table has. It has columns, records, constraints. And the three types of constraints are primary, key integrity. The constraints are used to maintain primary key integrity, domain integrity, and referential integrity. Now, how do we create a table? And something you'll see in the notes is that we always will have syntax, okay? And the way I would like to use this, I think should be used, is you can just refer to the syntax and you plug stuff in, okay? Or as my old chemistry teacher used to say, you have formula, you plug and chug. So if you look here, this is showing us what the syntax is for creating a table. There's going to be the create table keyword, followed by a table name. There's an open brace, and then we have a certain number of columns. The first thing we put between each column, we have what? A comma. And each column will say first the name, the data type, and there might be some optional parameters. Okay, so let's see, is there an example in here? So some of that you'll see. Um, So something that we'll see that each column must have a name, right? Because that's one of the things that a table has to have. That's one of the properties. Each column must have a name. Immediately after the field name, we put the data type. And then the column definitions are separated by a comma. And all the table's properties are between what? An opening and a closing brace. And it doesn't say it here, but the optional properties generally have to deal with domain constraints. Okay, some of them will also have referential constraints for referential integrity or primary key. So let's look at an example. Over here, you can see it. There's what that they've made that there's a database called what Boxcar Press, and we always have to say which database we're making the table in. And you can see in here there's a create table, right? And then we can see this has a certain number of columns. So we see, and then there's the data types, and they're all separated by commas. And there's a second table over here, and some others. And so I'll show you how I would go about doing stuff. So maybe right now, I'm not so sure. I would just select this, Control C, Alt Tab, and I'll do Control V. So you see now, I will tab this over, and with what you look at, there's some things with the editing. And you see, it makes a few things with editing. But now, let's say I want to call this table, let's make a table about bicycles. So you see I put in a name there. What's one of the data type? Well, each bicycle has a manufacturer or manufacturer, right? And what data type should I use for that? I think I will use, let me use varchar 50, right? And it will have a frame size. Frame sizes tend to be, let me say this is going to be in, they tend, at least in the US, in inches. So it's probably good to say what it is, that frame size. And maybe let me put the units, frame size, inches. And that will be int, right? And I'll do another one. Wheel size, wheel diameter. And that was, I think that is also tends to be in inches. Let me just say int. And what else could we set? I could say model varchar 50. And year. I'll say, I have to say, we can't use the keyword year because that's a SQL keyword. So let me say sale year or model, yeah, sale year. And I'll make that date. okay? Because there isn't there isn't a year data type, right? I can restrict this to date later. And what else will I put in? Um, oh yeah, I can put in style, and that will be Raka. Make that also 50. You see, I'm using a lot of this, and then we'll also say serial number. Okay, serial numbers. Don't want to use an int because they might have letters in there. Okay. I might also have things like leading zeros. So I'll just use car. Let me say, assume that they're all the same. Car maybe 15. And that's it. Okay. So you'll see most of this stuff. I didn't put anything like the owner of the bike or anything like that because that's going to be we define a bike in terms of only itself, right? So a bike can have different owners. It can be in a different place. That's why I didn't put that in there. I could even take out the manufacturer because manufacturers will have different. Um, Ideally, what I would have is I'd have a manufacturer table and probably a style table. But this is a good place to start. So I've made this table. Then how do you actually have SQL? You create. So I've written the statement, make a table, and how will I actually now tell SQL to create the table? So what I'll do, all you have to do, so I'll go check the database, and if I hit F5, execute, you see it says it's completed successfully. I don't see anything. If I want to see a table, I go to test, to the database. I go to tables. There it is, DBO bicycles. You can see the columns. All right. So that's how we create a table. And you see this, it's very useful to use the notes and just plug and chug stuff. Um, I don't think you should spend a lot of time trying to cram stuff. You should spend a lot of time trying to do examples and exercises. And as you keep doing them, you'll start to see the pattern. Okay. So what's the next thing we wanted to talk about? I'll talk briefly about computed columns. What's a computed column? Well, um, sometimes we might have a column that's based on some values in some other columns, and that's a computed column. And then over here, you see an example where they have weekly pay. You know, we have the gross pay, the payroll tax rate, and then people might have deductions, and then there's a net pay. That's what they take home. But you see, it's based on what gross pay minus gross pay times the tax rate plus total deductions. So you'll see these other columns, which are not computed, have data type. This one doesn't. That's it. And then there's an example in the notes of how you can use it for other things like uh, text-based data. Now, what's a schema? In databases, you'll find schemas a lot. The reason why we like to have a schema is that it helps with permissions. It makes a namespace smaller and more manageable, and then we can group things together. A schema is not that complicated. Just think of it as kind of like a container for things that need to be together. So in here they give an example of making a schema for the author, book, and genre. Why do you do that? Because there's maybe 3 or 4 tables have to deal with the author, another 3 or 4 tables have to deal with books and other things. And if you look in the notes, you'll see that the table names are fairly long. If I go back here, see what did they say? Author contact info, author bios, right? And then they have these columns that you're trying to make descriptive books information, book editorial log. But now with a schema, they're able to just uh, group those all, and that way we can have nicer table names. It's more readable. So how do you make a schema? Basically, you see an example here. There's a crate. You do a schema, what has to be in its own batch. Okay, and this is the syntax for it. I know that the fonts make it look a little bit odd. So if you also look at the code, you see how it's written. So generally when you do a create schema, it's going to be create schema name. Just like we've seen with create with other things. But this can be the only thing inside a batch. What's a batch? It's a set of statements between two goes. So what does that mean? You have in the between two goes, you can only have a create schema. You can't have anything else. We see in this example, between two goes, there's only a single schema. So after they made the schema, how do you tell the table to be in a schema? Use a dot, right? So you see over here, what did they do? You dropped this author contacts info with that long horrible name. They dropped author bios. And then they made this table. You can see it's create table, and there's a schema over here, a dot, and then the table name. So this is more readable also. So it's basically the same thing. And then they over here they also dropping these tables and putting them inside their own schemas. So you see it now. Okay. So next thing I want to talk about is naming conventions. As you see, we're always trying to make people usually don't have time to do stuff. We tend to be always in a hurry. So if you make it, and if people have to go find it very confusing, it will take them longer. They'll have to, they might also make mistakes if you keep changing the way things are named or defined. So we always want to have a consistency in how we name and do things. And we also want to make it easy for us, right, to be able to tell what something is. So there's conventions in the industry, and then there's conventions used in this book. Um, the most important thing is be consistent. So over here they talk about if you have a column called product serial in one table, don't suddenly start changing in others to serial products or numbers. It'll be confusing. Okay, you don't need to put prefixes in the name. In some programming languages, people would put a prefix. So they might say something like, um, they might put the data type in the name. Okay, that's usually, we don't see that a lot nowadays. It's not always very helpful. It can also be confusing. So, for example, I mentioned here in the notes, let's say we have a table called customers, right? And inside that, we have, well, let me write the table. That will make it clear, I think. So if I make a table, this is what, I'll go to new query. Also, it can be helpful to you when you're working to always make a new query editor. Uh, so that way you can keep track of things much more easily. And if you don't need something, you can always close it and go back. So this is the way I like to write my create tables from scratch. I will do create table, table name. This is called customers. And I'll put the opening brace. Go down one line, put the closing brace, semicolon, enter, go back. And then, why do I like to do that? Because that way I don't forget the opening and closing brace. And also while I'm here, before I do that, let me make a schema. So remember I have to put, the schema has to be the only thing between two goes, so I'll go. And I'll go create schema customer. And I like to use a convention of making a schema name a singular thing because it's a category. Okay, so so if it's a category, I don't need to use a plural name for it. Okay, so you see how I made a customer, and now I have a customers table in here. I might have an account table in there or an order table also. So that's why I might have this customer stuff. Then I might have a vendor, right? A supplier. So I might have some duplication. So let me make a customers table. And what do I need for a customer? I need maybe I give them an ID, make that an int. And I might have a first name. Actually, I have contact person ID. Why do I have a contact person ID? Because I'm going to make another table of contact people. Let me make that car 10. And street address car 100. Oh, typo. City car 100 again. Oh, closing brace. So you see with the red squigglies, I can see it gives me an idea where there's an error. So street, city, zip, car 5, state, car 2, website, car 100, email, phone, car 14, right? So I've made this customer table. Why don't I make a customer account table too? So you can see why I might use a schema. Create table customer dot orders. Customer dot invoices. Let me call it that, yeah. So what will be on the invoices is going to be what? The customer ID, and there's going to be the ID, the invoice ID. So I'll just call that, let me call that int also. It's going to be the total price, make that small money. And total tax, small money. And there's going to be the timestamp. So date time 2. Okay. So you see now with this I can put stuff in there. And let's say, and then I'll make a contact person ID table. Customer, and call it representatives. Or I should probably call it well, let's go. That's fine. And what will that representative have? They have a customer ID, which will be an int. The representative will have their own ID. So let's make that car 15. Let me car 10. I'll make this customer ID is what? Car 10. Okay, and we also have first name, last name, and we'll have email, phone. Right. So with this now, So now let's make this. So if execute and if we go here and refresh this tables, you can see that we have these three customer tables. And I'll go back here and let's drop these tables. So I'll go drop table customer dot customers customer dot. Okay, so I'm going to drop these. And when you see this, it's putting uh, red squiggly and saying things don't exist. I can always go to IntelliSense, refresh local cache, and you see it fixes that. So now I'm going to drop these, but before I drop that, why did I want to do this? Let's say I change this to customer, put this here, Control V, Control V, Control V. This is something that people will sometimes do. Do you see how confusing it makes things? I could make it a little bit more readable with camel casing, but it's not helpful because now you see, what will I say here? I'm going to say representative. So do you see how not helpful this is? You don't ever need to do that. So I'll undo all the changes by doing Control Z. Okay. And so you see I'm trying to use a consistent naming scheme. I'm also using consistent format. Let's go back to the notes. So avoiding prefixes, we don't want to, we only want to use letters and names. They give an example here about if we have address 1 and 2, no, it's not clear what that is. If you can't think of a name for it, then maybe you shouldn't put it in the table, okay, in the column. You should have a column for that. So we have a billing address, shipping address, it's very clear. The table names should also be descriptive, okay? So this table, we have no idea what that means. If we have a tomatoes database, we have a varieties table, okay? People can tell right away. And another rule of thumb is to help people read is since a table is a collection of things, use plural for table names. A column represents a property, and it's only single, so it should be singular for column names. Okay, so you see over here, and they also, you might notice that we use dotted notation. So if you, there's a cars.color, you can tell this is a column, that's a table, right? It's a people table with a first name column. We don't do things like this where it's plural, plural. Okay, what are the naming conventions used in this book? Servers and database engines, we use all caps. Databases, camel casing with first letter in caps. Schema is lowercase. singular. Okay. When we use camel casing for this other word, and they always singular. Okay. Tables are going to be plural with camel casing, first letter lowercase. Columns also camel cased, um, the first letter when they're singular. So, and this is an error. There shouldn't be a second dot here, but this is a human resources database engine or SQL instance. The reports database, the manager schema, 6 months review table, and the about employee column. Okay. Sometimes you'll see if SQL auto generates the code, you'll see people putting things in square braces. And I'm giving an example over here of how you would do that. Okay. The next topic is we'll discuss how you alter a table. Um, most of the table alterations are going to involve either adding a column, index, or constraint, changing a column on index, removing an index, column, or constraint, renaming a column or a table. So you can do these ones with alter table. This one you have to use a special stored procedure for doing it. So the syntax for altering a column, for adding a column is this. So you see I'll just copy this. And I have this stuff in here. Let's say I want to add another column to the customer.customers. And if I can go in here, Control V. So I'll put the table name and schema, just copy that. Control C, Control V. And then I'll add, you see, notice I just have put the column name. Let's make this column um, employee count. Okay, and I'll make that data type int. That's it. Okay. And so does what? The next example, altering a column. So I'll look at this, Control C, copy. Why do I like to use that? It makes it easier, especially if I'm new to this. And I'll go Control V, and then I'll plug stuff in. So I want to let me alter the phone number, email. Okay. Maybe I want to, let me alter the phone number. So I'll just copy this, Control C. Note I have to use the schema also. And then, and this, it should say alter column, it should say column name. So I'll put column name, which is phone. Control V, and what data type do I want to use for it? Let's say I want to make it Control C. In cases extra characters or people use spaces, I want to change this to varchar 16. Okay. That's it. Now, how do I drop a column? I'll just do copy. and it will go in here. Now, if I want to drop a column, I'll drop a column from in here. Let me drop the total price. So the way I'll do that is Control V. I'll take the table name, Control C, Control V, and I can drop multiple columns. Well, I'll just drop. Which one will I? I'll drop the total tax. So let's run these. So if I do this, what happens? I execute, see it's completed, and if I go into the customer.customers columns, you'll see it there's now an employee count column, right? Go back to the editor. Note that if I go to the customer, representative, go to column, you can see, you see the phone is 14, right? I highlight this and I execute and I typo. Execute. Typo in the name. Yeah, and now if I refresh, you see it's now changed to 16. And the next one, if I go look at invoices, look at the columns, go here, and then I drop this and refresh, see the total tax is gone. Okay, so what's left for us to cover? I don't want to cover renaming tables because it's generally a bad idea. The notes talk about how to do it. You can rename a column. I feel like in production, when you don't know how columns are linked with each other, you might break things. I would say don't rename because you don't really know how many columns and tables might be linked. You might think you do, but you don't know. You can generate reports that will do that, but making sure that the change gets migrated everywhere in things outside the database is not something you can always guarantee. So I wouldn't redo that. If you're going to rename it, do it when you're still doing the design. I don't want to cover it because we won't be spending a lot of time on that. Now over here, there's an example of how you do constraints. So you'll see, generally we can only either drop a constraint or add. And there's other syntax for doing it, but I like using this because it's consistent. It also kind of matches how you do things for a table and it gives you an idea. It gives you a consistent pattern. Uh, you can also take away the constraint word. You can drop multiple constraints, and that's it for this chapter.